Hey everybody, welcome to day 3 of our geometry notes, basic definitions. Again, reminder with your notes, please take notes on the Cami and that you can pause, rewind, fast forward, etc. At times I'm going to ask you to pause. Also, please jot down any questions you have and bring them to class. So segment addition. So the first thing we need to talk about is betweenness of points. Point M is between points P and Q if and only if P, Q, and M are collinear. So betweenness is exactly what it sounds like, except for they have to make a line. So what this means, if I have point P and Q that form the line segment, PQ, M is between if it's someplace on segment PQ and in between P and Q. This means that we have what's called segment addition, where if I take PM, which I'm going to highlight in pink, and add it to MQ, which I'm going to highlight in yellow, I get PQ, which is the whole blue thing. This is called segment addition. If 3 points are collinear, then they can be added together. So for our first example here, it says to draw RS. Point P is on RS, and it tells me RP is 2, PS is 7, so that means RS is 2 plus 7, which equals 9. Pretty simple. So then here we have EG, where F is a point on EG. And notice I'm not measuring, I'm just drawing a segment, putting F in the middle. EG, which is the whole segment, is 100. EF is 4x minus 20. And FG is 2x plus 30. So again, our segment addition tells us that EF plus FG is equal to EG. So EF is 4x minus 20 plus FG, which is 2x plus 30, equals our whole segment, which is EG, which is 100. And then we have a basic algebraic equation to solve there. So that gives me 6x plus 10 equals 100. 6x equals 90. X equals I was waiting down my calculator there. 15, which is what I thought, but I do still have summer brain a little bit. So then there's this idea of segment subtraction. It's exactly the same thing as segment addition, except for it means subtraction. So if I have RS, which is the whole segment, and P is a point on the segment, RS is 24, RP is 10. So we could do this problem using our segment addition, which is RP plus PS equals RS, or the idea of segment subtraction is that RS minus RP equals PS. So again, I just kind of rearranged that algebraic equation, and then it's 24 minus 10 equals PS, because RS is 24, RP is 10, which means 14 equals PS. That's segment subtraction. Congruent segment. Segments are congruent if they have the same measure. So if I have AB, which is 3, and I have another segment CD, which is 3, we'll say inches, because it does matter, they have the same units. AB is congruent to CD. Now we can note that they're congruent by, on the actual segments, putting a dash through them. So that pink thing I just drew there, if you had multiple segments, you would do multiple dashes, like in our below example. How we write that is we say AB with a segment over it is congruent, which is an equal sign with a tilde above it, to CD segment. Example, using the markings to describe which of the following statements is incorrect. So if we look, it's indicating that this part is congruent to this part. So that means AB is congruent to CD. So that's choice 1, that's congruent. Well, if AB is congruent to CD, that means they're equal in measure. So that's part 2. Now it says AC is congruent to BD. So let's think about that. What is different if I go from A to C, which I'm going to color in pink, A to C, and then if I color B to D in green, B to D. So I have A, B, and C, D in each of those in part. And then this middle part, BC, is added to both. So that indeed is actually true because the parts are equal. Now, AC is not equal to CD because AC goes from A all the way over to C, and CD is just the little part. So the one that is untrue is 4. So our classwork tomorrow is in our textbook. Please make sure you bring that with you. And if you have any questions, or not your textbook, but it's in your Chromebook, please make sure you know your username and login. And if you have any questions, bring them to class.